All right, welcome class. This is going to be week 17's homework solution for Math 8 here. We have Monday, December 2nd, 2019. It says use the scatter plot to answer questions 1 through 4. I didn't have room. It's only 3 questions, okay? So make sure you understand it's only up to 3, okay? So I could just erase this if you want, and I can write the number 3 here. Makes you feel better. All right, so the scatter plot here shows the result where 3 students, archeries, each make 9 attempts to hit a target. Okay, here are the attempts. Okay, and here, I don't know if you know what an archery is, but it's a person, they have a bow and arrow, and they shoot. And what do they mean by a bullseye is that there's a circle, and there's a circle, and in the middle, there's something called a bullseye, and you try to hit it as close as possible. Okay, and this is how close they are to the bullseye. All right, so each data here represents the distance in each that the attempt from the bullseye. So here, so the first attempt, one person hit 10 feet away from the bullseye, another person hit 12 inches away from the bullseye, and another person hit 18. Okay, so here you're looking for an outlier. Okay, if you remember what an outlier is from class, an outlier is defined as a value that falls dramatically outside the pattern. Here we could see like there's a general pattern. Let me help you out by isolating the pattern for you. Okay, the pattern looks like it follows right here. Okay, do you see how all of it is mostly in this area? Okay, it seems like there are two values here that apparently don't fall in that. Okay, they look like this value, which is what, the 8 and 18. So the 8th attempt was 18 away, and right here, sorry, this is wrong. The 7th attempt was 17 inches away, and was the eighth attempt was 16 inches away. Okay, so the reason why these points here are considered outliers is because they fall dramatically outside this pattern. So we can write it right here as the answer. What are the order pairs that you could classify as outliers? We could say it is the 7 attempt and they result in 18 inches away from the bullseye. Also, we can say another one was the 8th attempt at 16 inches. All right. Okay. Here are your two outliers. Why do outliers occur? Well, in nature, outliers will always occur because things don't always follow the pattern. Okay. All right. Good. Next, which statement describes the pattern in this data or the relationship between the variables after you remove the outlier? So let's remove these two. Okay, so let me just erase it to make your life easier. Okay, I'm going to erase the outlier. Whoop, right here. So, right, that's what I say, removing the outlier. Just looking at this pattern. Okay, what can you say here? Okay, once you move it, does the pattern become less linear? Or, in other words, does the pattern form less of a line? No, it looks like it makes more of a line. So we would say that this is wrong. The pattern of the data shows a strong association. Is there a strong association? Yes. Okay, we would say yes. Okay, there is a stronger association. And what do I mean by association? Is that stronger association. And what do I mean by that? Is that the dots, the data are closer together. All right. The pattern becomes more linear. Oops. So hold on. So this was correct. And does it become more of a line? Yes, because the data gets closer. So this is also correct. And the data of the point shows a weaker association. No. Okay, so something for you to talk about association is that association just refers to how close the data is to each other, how associated they are. Okay, next, which statement best describes the correlation between the attempt numbers and the distance? Okay, so we never really talked about this in class, but I want to also bring it up. I want to define each one of this for you. Okay, because some of you are looking at your notes and it doesn't make sense. Here, it's a good time if you want to watch another video or go to Math is Fun or just Google what these words are. That would also be help you if you would like to see how it looks like better. Okay, a strong positive correlation. How does a strong positive correlation look like? A strong positive correlation would look like something. Let's see if I could make dots. Would look like something like this. Trying to make dots. Ooh. Oh, okay. Strong positive correlation would look something like this. Okay, this would be strong positive correlation. Okay. Now I'm going to show you what a strong negative correlation is. Okay. But this time goes down because it's negative. Okay. And this is strong. Now I'm going to show you the weak positive. Okay. I'm going to make this blue. Okay, this is weak positive. Okay. Notice how the points here are more scattered. And let me show you what negative correlation is. Negative, this is a weak, negative weak. Yeah. I'm going to show you now what negative weak is. This one will look like something like this. Okay. Notice how it is going down, but it's more spread apart. That's what it means by correlation. Correlation, by definition, if you would like to know, correlation refers to how far apart the points are from each other. Okay, or how far scattered would be a better word. Apart the points are from each other. Each other. Yep, there you go. Okay. So looking at this one, okay, does this one have a positive? Does it have a strong positive, strong negative, weak weak positive, or weak negative? Okay, it looks like it's going negative, so we can cut these two out. Okay. So is this strong or weak? Okay, it seems like it's more spread apart, so I would say it is a weak negative correlation. Why? Because the points here are more spread apart. Okay, all right, there you go. Those are all your homework solution for Monday, December 2nd for week 17.